Swayam Prabha. Digital India. Educated India.
Hello, namaste. Today we would look at the lecture 4 of the module 1, where we would be looking at concepts of how we acquire data. This is very important part. I would be introducing certain data sources where you can get data. So we have sufficient data. When we look at Indian subcontinent, every data is available for the users. Only thing is how we access it is the thing that we have to understand. So the first thing that I would speak about is how we acquire this data. Then the second thing is looking at spatial data source and generation. What are there certain data sources which can be used, or can we generate these data from different sources, is the thing that we would look at in the next part of the lecture. The third part would be GIS as an attribute data. So how attribute data is used as a GIS capability is what we will understand. And finally we would look at how we will display the data, how the integration of data will be happening, and with this look at the entire capability of GIS. So with this lectures I am trying to show you how the data generation happens to the analysis part. So this is just an introduction part of how GIS works, but if you can understand how the spatial data is acquired to the data display and integration, it would be extremely helpful in understanding this as a basic part. So when we look at data acquisition is normally the first step of whoever starts looking at GIS. Whether it is GIS or whether it is any other part of research, the first thing that everyone has to understand is how do you get data. Okay, the many research scholars who look at the first thing, they give extremely good research questions, but they would not know the sources of data. The first thing that everyone has to look at is that first look at the source of data, then is what your proposal comes. The first thing, so when we look at Indian context, since 2010 most of the government agencies at different levels have set up data for public sharing. So most of this data is available and is geographically referenced. Most states, most of the government agencies have put the data in the open domain. The spatial data acquisition, there are different methods of acquisition. For example, some of the spatial data can be acquired using interviews, the land surveying, and the numerical methods. There are huge ways of looking at different models and methods in order to do the ground based acquisition. Then laboratory measurements for of samples. For example, you go to the field, collect samples, come back to the laboratory, analyze those samples. Then you have measurement by in situ sensors. This is what is the thing of today. So you have sensors that are that are available at a very less cost, and even it is designed by many of us who can understand how the sensor works. So the measurement by in situ sensors are one of those aspects that people have taken out in a great way in understanding the ground based acquisition. So you don't need any human resource, but you have a sensor there on the ground which gives you all the time all the data that is required for any kind of analysis. So when we look at spatial data acquisition, so from the ground to the spatial data, we can look at sensors. It may be aerial cameras, it may be spaceborne sensors, it may be your satellites, it can be scanners, something like radar and lidars, and this is what is revolutionizing the way the data is acquired. Now the data, because of the new regulations, government of India is now pushing into so that the geographic data can be collected using the UAVs or the drones. So that has made it more easily available data for the users. So That's how the data acquisition starts, and it can be, the data can be acquired from various portals. For example, if someone wants to get Survey of India topo sheets, now government has made it most of the topo sheets as digital. So anyone who wants to access these topo sheets can go into the Survey of India portal, which is mentioned here. It is soinakshay.uk.gov.in. so if you can go into this particular website, you will be welcomed by this particular prompt. So once you are welcomed by this prompt, you have to just log in, where you have to provide your VID or an Aadhaar number. If the Aadhaar number is added here, and you have to enter the captcha code. So once you enter the captcha code, you get an OTP on your registered mobile number with the Aadhaar. So that OTP is entered here. You will be able to access the map that you would need. Only how to access these maps, what kind of maps is required, what is the scale of this map, etc., that we'll understand it but at a later stage. But now it is one of the data sources. If you want to get certain data of a particular place, that can be got. One of the sources is nothing but Survey of India portal. It is extremely good, lot of information is put on the website. So if someone is interested, please look at it. I would suggest everyone looking at it. The next data source, if someone is looking at remotely sensed data, there are huge number of free resources available, but very well known medium resolution satellite is nothing but Landsat. So this Landsat data can be easily downloaded using Earth Explorer. Earth Explorer also gives you Indian satellites data. Now certain data of list 3, list 4 sensors are actually given by the USGS. So this is a website where you can download some of the satellite data. Just go in, give the address, name and place, and from what date to what date. So it gives you the geographic information when you give the name of a place, and once you give what date to what date, it will ask you what are the data sets you need, whether you need remotely sensed data, or whether you need certain attribute data, etc. Every data set is listed here. So once you click on this submit, so you can find out there are large number of data sets available from almost from 1980s to till date. So, and you can also see what's the quality of data. If you are okay with the quality of data, then it can be easily downloaded free of cost. Only thing is you have to create your own account into this portal, and then you are free to download. The third and the most referred aspect is Bhuvan. It's India's own website that actually showcases how geospatial data, the geospatial information has progressed over past 2-3 decades in Indian context. So when we look at Bhuvan is a portal which also gives you a lot of data. For example, you have a Bhuvan 2D data, you have a Bhuvan 3D data. 3D data is something like your Google Earth. Then you have Open Data Archive. This has a huge sets of data that is available for in Indian context. Then you have a climate and environmental data. These are your derived products. Then you have thematic services. So you can, with certain analytics, you can even look at how the different thematic structures. For example, if I am trying to look at what's the literacy rate across India, if you can go here, this thematic services will give you the entire literacy rate, where the literacy is high, where the literacy is low, where the literacy is reaching at good levels. So looking at that, one can understand which states has to be have to be given more of concentration in order to develop it. So that is what with thematic structures. Then we'll also look at thematic services when we are actually looking on the software also. Then disaster management support system, this is what I was speaking about Uttarakhand floods in my previous class. Then you have ocean services, and most important is you can create a map in using this particular portal. It means to say you can download probably the boundaries of particular regions. You can create your own maps, you can get subsets of that data. So all of this can be done. So And second thing that also they give us information services, which means services in terms of flood warning, flood vulnerability. Census data is made available on Bhuvan, which is the new thing that I've seen, the way it has been represented, the deltas of India, the environment and forest in India. So every information from every ministry is being put into the single portal. So these are various things that you can find it on Bhuvan. And most importantly is that you get a remote sensing satellite data of Indian remote sensing satellites, IRS list 3, and also if you want to understand the elevation of a region, you get Cartodem. So this resolution is about 23.5 meters. So you can download this data for free from 2008 or 9 till 2019. The data is available free of cost. So anyone who wants to work on remote sensing data and GIS data, there is a one-stop portal where most of the things of Indian subcontinent can be easily found. So you also have state remote sensing portals. Every state has its own remote sensing centers, which are otherwise called state remote sensing centers. You can go to those portals, download a lot of information that is available. Many of those have an interactive website wherein the data is available. Then the biggest source of the data generation for any of the analysis is OSM, the OpenStreetMaps. So one thing is you have free data in terms of point, line and polygon. So if you go to this particular website, you can find out what OpenStreetMaps are. They are extremely interactive. They give you huge amount of information. Many of your maps, many of your data outputs are based on this OpenStreetMaps. So another big data source is Google Earth. So I hope many of you would have either used, seen this, maybe in various ways. It may be in your movies, it may be in various other issues. You see Google Earth as one of the major aspects that in order to pointing out a geographic place. So you can create free vector data. I'll say what is a vector data. So as of now you can create free the point, lines and polygons. Point is to represent a particular, maybe a building, line is to represent a road segment, maybe a polygon is to represent an area. So you can create it by yourself. You can look at 3D buildings, look at terrain visualization and more. So all of these capabilities are inbuilt with Google Earth. And very recent development that actually is taking the research community by a real storm is Google Earth Engine. Extremely good. This has its own data sets. The data sets is already available. The codes of various algorithms are already available. You can use Python to code it, and this helps. This is a platform which gives you, without even having a system, it can give you the entire output. The exploit analysis etc. can be done in a much easier way without having a capable system with you. So Google Earth Engine is extremely capable and has a huge amount of data that has been stored. So analysis, data combined is what is GIS. So you have everything. You have data, you have analysis capability, and the information can be put out. For example, there is one of the information that was put out by Google Earth Engine, where it is providing a climate model from a Google Earth Engine. One of the models, the data that is in a dynamic nature, it is exhibiting how that climate is changing over a period of time. So this is about data generations or acquisition. So very important part of data acquisition where people miss is metadata. The first and foremost important thing that has to be seen when you are acquiring a data is a metadata. Metadata provides answers to, for example, who, where, what, now, how, when and why. So when I say who, it's about who has actually created the database, who manages the data. For example, if there is an updation every 5 years, who is the person who is doing the data? Because you should know the legitimate quality of that data. If the quality of data is bad, then downloading that data is of no use. So that tells, the metadata gives you information of who is doing it. So if it is really a good source, maybe a government source or maybe any other source which is extremely good, so it may be useful. Where it is means where this particular study area is. For example, if you have downloaded satellite data, it tells you where this location is, giving you the coordinates. Can I access the data? Is it a source data? So what is the kind of source from where it has been acquired? So it is not that it's just passed on from one source to other. What kind of data it is, what is the data content, what are the data, what is actually it is providing as a data, then what are the source to generate that data is been used, whether it is collected over GPS, whether it is collected over sensor, or what daytime, night time, or what part of the time, is it morning, evening, afternoon. So all of this, zenith angle, all of these will be put in to the metadata. Then you have how the data is created, what are the procedures that has been used to create this data. Then is the period of the content what is the period of the content and when it has been created. Then was the data created, are there any missing values. So all of these will be in the metadata. So whenever anyone is looking at any data source which is not generated by you, the first thing is look at the metadata. Metadata is data about data. So if you have not understood what is the metadata, so if you have not seen the metadata, then there is every chance of your information going wrong when you are extracting information from a data. So when we look at metadata, the very core components is you have metadata record information, you have identification information, you have constraints. So this is very important part. So constraints will give you what is actually the thing that the information that can be extracted from your data. Data quality information, so how good is the data, if it has clouds, if it doesn't have clouds, if it has certain errors, if it doesn't have errors, it has scan lines, it doesn't have scan lines. So all of this information will be put into it. You have maintenance information, the very important aspect, the spatial information, where is it located. Then the reference system, what kind of reference system, because when you are analyzing data, everything should be in the same reference system. This is very extremely very important. Then when for example, if you have one data in one reference system and other data in another reference system, so when you overlay both of these, one will sit maybe in America and another one will sit in maybe in somewhere in India. So if both are not of the same reference system, so these are digitally divided, so it has to be in the same reference system. Then you have content information, that is important in terms of you understanding what is the content. Then the final thing is symbology. What symbology is used in that data, because every data has its own way of representation, and when there is a sharing of publicly, the metadata acquisition is extremely important, especially the public data, whatever you are downloading. Metadata stores almost all information about layer, image or data. For example, on your right hand side I have given a list of the metadata. For example, here GeoTIFF is a format that is provided by GDAL. So this is the driver that is actually giving you this, the format of this image. Then the data set description, it is an elevation data, so it's elevation.tif. so this is where it is stored. Okay, so what is the dimension of data? It is 7200 rows by 7200 columns, and it is only one band data. So then origin is this, then you have a pixel size, each pixel is 30 meter by 30 meter. Data type is an integer 16-bit data, 16-bit integer type. So similarly you have the projection is UTM, zone is 43, datum is WGS 84 and units is meters. So this is what has to be similar for all the layers that you are trying to analyze. Then what is the layer extent? So it gives you the original layer, and so this all the coordinates that is in this particular projection system. So this is about the metadata. So as I did say, data can also be digitized using orthophotos. Orthophotos are extremely capable ways of looking at data. So these are created from satellite images, or maybe even converted from GPS data, survey data with specific coordinate information. So orthophotos are also a good source of deriving data layers. Then data acquisition may involve both new and old data, in terms that these both data have to be analyzed for any analysis of a certain GIS based operation must necessarily match these informations, for example the geographic information, the coordinate information, etc. Additionally, both existing and new spatial data must be edited if they contain digitizing errors. This is the first step in analyzing any spatial data. If you have any errors, topological or digitizing errors, this has to be removed. So we will also look at some of the errors. For example, when you look at topological errors, you have something like a dangle, you miss this particular line. So you have a switchbacks when you are actually drawing a line. So somewhere you have a switchback, somewhere you have an error when you are actually creating, because you are actually doing it on using a mouse or maybe a digitizer. So such things have to be removed. Or you have something like a silver which has a overshadowed polygon, or you have something like a gap which is an undershadowed polygon, you have a gap between a polygons. So something like this has to be corrected. I have shown here how the topological editing is done. We will go through in details of it in our coming lectures. This is a non-topological editing. So the next set is attribute data in GIS. GIS has a database management system that can handle attribute data, but these attribute data are most likely stored in the relational databases, and when we look at this, tables can be prepared, maintained, edited separately. All of these tables can be edited separately, and only thing is that you have linkages. So you can look at mathematical, you can look at statistical and database related operations that can be performed on all of these tables in any of those attribute data in a GIS. So the final part is looking at GIS as a display. So this is you have to look at the representative factor for any of the map making plots or final interfaces of GIS. So how do you represent a particular map? That is essentially important. We will look at every part of a map also. We will understand how maps are done, what are the different parts of a map, how maps are organized, etc. It involves selecting the symbols to represent features, symbolizing the layer based on attribute values, using different classification methods. It can be any kind of classification methods. We would look at it when we are actually looking at how different map features are there, and maybe in the 7th or 8th week of this course. So in order to summarize, we have data acquisition. The first thing is we look at ground based and image based techniques. So I have given you a good number of links where the data is available. I would suggest everyone to look at each and every link, because this has good data sources. If you become familiar with the data sources, it would be very easy for you to understand different aspects as you move ahead in this course. So the first thing is look at some data. So once you have this course can only be learnt with data and more practice. So understanding data and having more practice is extremely important to be more successful. So when we look at data source and generation, we looked at SOI Nakshe, which is really good as far as the governmental data set is concerned. This gives you everything based on maps. Then you have USGS Earth Explorer, where it is a well known Landsat data set provider, along with various other data. Even I did inform you about the Indian satellites data that is available. Then you have Bhuvan. Bhuvan has extreme capability of how we look at data, how different data sets are there, what kind of data is available, and how you can utilize Bhuvan itself as a platform in generating a data. Then we looked at OpenStreetMaps and its features, Google Earth and Google Earth Engine. So if time permits, I would request everyone to look at Google Earth Engine and it can be extremely innovative, and it can help you out in your career in a better way. So we looked at what is a metadata, what are the characteristics of a metadata. Then we did even look at what is attribute data and how they are linked. It need not be just in a form of a columns in a single sheet, but this data can be over multiple data sheets and it can be linked over by different aspects. Then you have a data display and mapping system. So this data display and mapping system is where the last part of it, where you add in what are the map characteristics is required, what are the different labels are required, different map placemakers are needed in order to define that as a final map. So with this we come to end of today's lecture. So we will look at more aspects of how the data can be used in the next class. So thank you till then.